All right, so let's try this one now. This is section 7.1. Here's your introductory lecture. This will go along with those examples you already have. In fact, I will update this particular content sheet in your Canvas course shell. So here's some detail for 7.1. I'm going to remind you that the lecture here is really designed to augment and support both your text and the online PowerPoint lecture. It's also very important that students reach out with questions or comment either on our discussion boards or via email or email, I guess. Anyway, let me jump over to my other camera and we'll take a look at the 7.1 material. All right, 7.1, we're going to estimate population proportions. You have several examples already in your notes, so I'll run through this rather quickly. We're going to use p hat equals x over n, and this is going to give us the proportion of our sample, and we're going to use that to estimate our population proportion, and that's p, x, in this case, over big N. Remember now, x are the number of elements, items, or people that share a particular characteristic. Little n is your sample size. Down here, same x, big N is your size of your population. In terms of a picture, what we want to do is we want to use, and I like pie chart for this one here. We have a total of n observations. We're going to use that to estimate our population proportion. Why do we do that? When do we do that? Well, the validity of our estimate comes to us from the central limit theorem. And we realize that p hat should be close to p, basically when your sample size is greater than 30. And that's really what we're going to count on. We're going to take a look at the formula. Then we're going to take a look at our TI-84. We have a special tool, the TI-84, to handle the confidence interval for a population proportion, and it is the one Prof Z interval tool. So we'll go ahead and we'll take a look and find out where this guy is. We'll take a look at our formula, and then we'll take a look at an example. Some vocabulary first. We have our point estimate. That is our best guess. Our point estimate, the best guess as to what the true parameter is, that is our p hat value. That's the x over n. That comes to us from our sample, and it's really one of the few things we know for sure. We're going to take that point estimate and add to it the margin of error. And that margin of error is given to us by the letter E, and we actually have a formula. The formula is quite impressive. Z alpha over 2 times the square root p hat q hat all over n. The Z alpha over 2 is one of those critical values, and it is set by the level of confidence. p hat n and q hat equaling 1 minus p hat come to us from our sample. So we build our confidence interval in the following fashion. Confidence interval, by the way, I use CI all the time because it's a rather wordy little statement. So our confidence interval begins with my point estimate, and I add and subtract the margin of error. In terms of the formula you see in your book, we have p hat equals, excuse me, p hat plus or minus the z alpha over 2 times the sample factor. So there we go. Now, we're going to use our calculator to try one of these and see if we can develop our confidence interval. So this is a very basic example. You'll have more involved examples in your PowerPoint and on your homework. So please try those and take a look at the other videos too. There's more examples there. So for this particular example, X is 39, my sample size is 84, and we're going to construct the 90% confidence interval. So here's my calculator. It's fairly readable. Stats, all the way over to tests. I'll scroll down tests all the way to the one prop Z interval. It's on the second screen. And here I can input the value for X, 39, N is 84, and my level of confidence, 0.90. So our 90% level of confidence, that means that alpha, by the way, is 10%. That's what's split between those two tails. That's giving us the Z alpha over 2. We're going to calculate it. I blow on it once for luck, and there we go. I'll note that we have our point estimate as well as the confidence interval. I like 3 decimal places here. There is no hard and fast rounding rule. I'll write 0.375 less than p, the parameter that is being estimated, less than 0.55. 37, so 554. I will note the point estimate in the middle of this interval is 0.464. So most examples will run somewhat similar to that. I will come back with another example or two later in the chapter. Thank you and goodbye.